Hi everybody, welcome from HVACR Design Engineering. I am Tuyao. Now, I want to talk about design equation in refrigeration system. First item is cooling load. Cooling load is a rate of heat energy removal from a given space. The common unit for cooling load is called ton of refrigeration. 1 ton of refrigeration is equal to 288,000 BTU per 24 hours. In other words, 1 ton of refrigeration means a removal of 288,000 BTU in 24 hours. Next, we look at refrigerant flow rate. Refrigerant flow rate represents the amount of refrigerant flowing in the refrigeration system per unit time. We can obtain that by dividing the cooling load, that is a rate of heat removal, divided by H2 minus H1. So, the refrigerant flow rate is cooling load divided by H2 minus H1. That represents the heat being removed in the evaporator section. Next, we look at the compressor and we look at their work done on the refrigerant by the compressor, and that equals the refrigerant flow rate times H3 minus H2. Note that H3 minus H2 on our pH diagram refer to the compressor between 0.1 and 0.2. Next, we look at the condenser. We consider the heat rejected by the condenser, that equals refrigerant flow rate times H3 minus H1. So, all the way from 2 to 3, in other means H3 to H1, that is the heat discharged by the condenser. We assume that the superheat that is also discharged between point 2 and point A is a part of heat rejected by the condenser. For the evaporator, the heat absorbed by the evaporator can be calculated as refrigerant flow rate times H2 minus H1. Note that H2 minus H1 represents the evaporator section, and that is the amount of heat that will be absorbed by the evaporator. In order to evaluate the performance of a refrigeration system, we calculate the time coefficient of performance. Coefficient of performance we also call COP. COP equal to H2 minus H1 divided by H3 minus H2. Note that H2 minus H1 is the section that represents how much heat is absorbed by the refrigerant. H3 minus H2 represents the amount of work done by the compressor on the refrigerant. Thank you very much for watching my video.